Hi guys, it's Mr. Bowman here. Doing another higher chemistry um, online video lesson for you guys. The LQ for this lesson is how much product is likely to be formed. This involves a lot of calculations and it is very difficult. So I would suggest having a revision guide with you or a textbook with you that you can look through as we go through. Okay, you've got to do it now in front of you. I'm not going to go through all of these and give you all the answers. Hopefully, this is stuff you can do based on previous time in school or from the previous two recordings that I've done. So have a look through, see if you can figure it out. You can pause it, spend as long as you need. When it gets to the last couple of questions, I have also added up the two formulas here for you so that you've got those there to have a go. Alright, so we're looking at, as I said, two higher points that come up in the specification and is triple only. So we're looking at what is a limiting reactant and how that controls how much is produced in a reaction, and this thing called stoichiometry, okay, which is the ratio. So as you can see there in the red box, in chemical reactions, one of the reactants is often added in excess and is not completely used up. The amount of product formed is determined by the reactant that is not in excess. This is called the limiting reactant. Okay, so last time we had a look at how moles can work out the ratio of reactants and products. That ratio is what is called the stoichiometry. Okay, and we're going to be looking at how we can calculate those using masses in this lesson. So if we're thinking about the limiting reactant and whether something is in excess or not in excess, imagine we're making brownies. Okay, so we've got the ingredients that we need to make those brownies on the left-hand side, and in the cupboard we've got this number of stuff for each of that ingredient. Okay, so a lot of it you can see there is either the same or more, but there's one thing there that where we don't have enough compared to the recipe, compared to the ingredients that we do need. So it's that one that determines how many brownies we can actually make. So have a look, see if you can figure out what it is, what would be the limiting reactant to make these brownies. So having a look down, you can see we've got exactly the right amount of butter, we've got more chocolate than we need, we've got more flour than we need, so they're in excess. And then it says we need 40 grams of cocoa powder, we've only got 30 grams of cocoa powder. So that is going to be our limiting reactant because we don't have enough, so that controls how much we would produce. Then we've got 100 grams of white chocolate, that's double the amount, so that's in excess. Right amount of milk chocolate, double the amount of eggs, and more caster sugar. So again, those are in excess. Okay, so we're going to have a look at how we can actually then go on to work out the limiting reactant. Okay, so it does involve more calculations. Those calculations are ones you have learnt already. They're nothing new, but you just have to think about how you apply them. Okay, so imagine you have 0.5 grams of ammonium chloride and 4 grams of calcium hydroxide. They're both heated together and they form ammonia. Okay, so the chemical equation for it is there underneath. So 2NH4Cl plus CaOH2 gives us 2NH2. So we need to work out what is the limiting reactant and then also calculate the mass of ammonia formed. So remember, ammonia is NH3. Okay, so which of the two going into it is going to be the limiting reactant? That's the first bit we need to work out. To do this, we use the calculation moles equals mass divided by mR. We need to work out the number of moles first. Now, if you look at the equation, it says that we've got 2 NH4Cl plus 1 CaOH2. So that's a ratio of 2 to 1. Okay. So that would mean essentially that if we had 2 moles of NH4Cl, it would react with 1 mole of calcium hydroxide. So the number of moles of calcium hydroxide is going to be the mass divided by the MR, the relative formula mass. But of calcium, 2 oxygens and 2 hydrogens. Okay, which will give us 0.0541 moles. So that's how many moles we will have in that equation based on the amounts that we've been given. Now, because it's a ratio of 2 to 1, that means that we need 2 lots of that. So 2 times 0.0541 equals 0.108 moles of NH4Cl to react with 0.0541 moles of calcium hydroxide. That would be the equation that we would need. Okay. Now it says that we only have 1.5 grams of the calcium hydroxide. Okay, so if we put that into the equation of moles equals mass divided by mR, our mass 1.5 grams divided by the relative formula mass is going to then be 0.028 moles. Now we can quite clearly see that we have less than the 0.0541 that we need for that reaction to take place at the correct ratio. So that means that the NH4Cl is going to be the limiting reactant. Okay, hopefully that makes sense. Again, if you're struggling, have a look through the book, textbook, or a revision guide. If you really are struggling, I'm going to be setting some chemistry work on Showbie, and feel free to ask any questions on there, or you can email me directly at my work email if you need to. Okay, so the second part, which is working out the mass of ammonia that is formed. Now, we've done all the hard calculations. You need to do that first bit to be able to do the second bit. Okay, so the equation shows the number of moles of ammonia made equals the number of moles of NH4Cl used, okay, of ammonium chloride. So you can see that on the equation there, you've got 2 NH4Cl will give us 2 NH3. So it's a ratio of 2 or 1 1. So that's nice and easy because that means you don't really need to change anything. 1 mole of ammonium chloride will give you 1 mole of ammonia. So that also means that 0.028 moles of ammonium chloride will give you 0.028 moles of ammonia. Put it back into our equation to work out the mass that we need. So the mass is going to be the moles times by the relative formula mass. So the moles, we just worked that out, 0.028 times by 14 plus 3, so times by 17, which should give us 0.476 grams. That is how much ammonia will be worked out in that equation. Spend a bit of time, go back over that, double check you understand how it works. The next thing we'll have to be able to do is you need to be able to use the masses to deduce the balanced equation. So you might get a question like this one here. If you had 10.8 grams of aluminium reacting with 42.6 grams of chlorine to produce aluminium chloride, you need to work out the balanced equation. Okay, straight away you probably look at it and think, I have no idea how to do that. Okay, it's really simple. Okay, first of all, again, same thing as before, you have to work out the number of moles. So to work out the number of moles, we do the mass divided by mR. So the mass of aluminium is going to be 10.8, and you divide that by 27, okay, which gives us 0.4. Now chlorine always travels around in pairs, so you need 2 lots of it. Okay, so you do the mass, which is 42.6, divided by 71. Okay, 1 on its own is 35.5, and the answer to that is 0.6. Okay, so that gives us 0.4 to 0.6. So this is where we're then working out the ratio. To work out the ratio of something, you divide both the numbers you have by the smallest number. So that means you get 0.4 divided by 0.4, which gives you 1. And then you do 0.6 divided by 0.4, and that gives us 1.5. Okay, so that's a ratio of 1 to 1.5. But when we're writing the formula equation, we're not going to have 1.5 of something, so we need to make it the simplest whole number ratio. So in this case, 1 to 1.5 will be a ratio of 2 to 3. So that means I have 2 aluminiums plus 3 chlorines gives us 2 aluminium chlorides. Okay, the final part, how you would balance that on the right hand side of the equation, you would just do by balancing the equation that you should know how to do. Okay, I'm going to give you some practice questions. We will go through the answers, but I suggest pausing this slide and pausing it on this screen and having a go at answering these questions. Okay, so the first one, what is a limiting reactant? You can go back in the video to have a look through for help for this if you need to. The second question, see if you can identify what the limiting reactant is and what reactant is in excess. When you're ready, press play again and move on. Okay, next question. So you're going to start doing some calculations in this one. So we've got 3.25 grams of zinc, and that reacts with an excess of hydrochloric acid to form 6.8 grams of chloride. Okay, describe what would happen to the amount of zinc chloride produced if the amount of zinc that reacted was doubled and the amount of hydrochloric acid stayed in excess. And B, how much zinc would react in an excess of hydrochloric acid to produce 1.36 grams of zinc chloride? Okay, again, pause this screen if you need to and see if you can work out those answers. Okay, next questions. Calculate the mass of potassium chloride that will be formed if 36.2 grams of aqueous potassium bromide reacts with an excess of chlorine. The balanced symbol equation for this reaction is 2 potassium bromide plus chlorine gives us 2 potassium chloride plus bromine. Okay, just if you aren't aware, aqueous means that the potassium bromide is in solution. And question 5. Calculate the mass of aluminium chloride that will be made if 15.4 grams of hydrochloric acid reacts with an excess of aluminium. The balance symbol equation for this reaction is 6HCl plus 2Al gives us 2AlCl3 plus 3H2. Again, pause this screen if you need to. Pause the screen if you need to and see how you get on with it. Press play when you're ready. Okay, so let's go through some of the answers to this then. So the first question, what is a limiting reactant? So nice and easy, it's a reactant that's used up completely in a reaction, or the reactant that limits the amount of product that's formed. Number 2, during an experiment, a small piece of sodium was added to a bowl of water. The sodium reacted with the water until the entire piece disappeared. Identify the limiting reactant. Okay, it's going to be the sodium because it all gets used up. The reactant in excess is going to be the water. Okay, there's still water left. Right, number 3, 3.25 grams of zinc reacts with an excess of hydrochloric acid to form 6.8 grams of zinc chloride. Describe what would happen to the amount of zinc chloride produced if the amount of zinc that reacted was doubled and the amount of hydrochloric acid stayed in excess. The amount of zinc chloride produced would double. Very simple. Okay, if the amount of zinc chloride produced, the amount of zinc doubles, the amount of zinc chloride is also going to double. And B, how much zinc would react in an excess of hydrochloric acid to produce 1.36 grams of zinc chloride? So we do 1.36 divided by 6.8. Okay, so 6.8 is the amount of zinc chloride from above, and that's going to give us 0.2. So the amount of zinc that reacts is going to be 0.2 times by the amount of zinc, 3.25, which equals 0.65 grams. Again, it's just about working out those ratios. Question 4. That's where it starts to get a bit more in depth. Calculate the mass of potassium chloride that will be formed if 36.2 grams of aqueous potassium bromide reacts with an excess of chlorine. The balance symbol equation for the reaction is there. Okay, so the first thing we need to do is work out the relative formula masses of both potassium bromide and potassium chloride. Okay, so use a periodic table, find the atomic masses, add them up. Okay, so potassium bromide is 119, potassium chloride is 74.5. So then we need to work out the relative amount of the potassium bromide. So we do 36.2 because that's the mass divided by the relative formula mass, which is 0.304. So that tells us that the number of moles that we've got is 0.304. Okay, it's that same formula that we've been using all the way through. Moles equals mass divided by mR. Now, if we look at the ratio, 2 molecules of potassium bromide react to form 2 molecules of KCl, or potassium chloride. So that means it's a ratio of 2 to 2 or 1 to 1. So the relative amounts of the reaction are going to be the same. So to work out the mass of potassium chloride, we use that same formula. Instead of working out the moles, we're working out the mass. So the mass equals moles times by mR. So the moles, we just worked out 0.304. And we're going to times that by the mR, times by 74.5, which means we will have 22.7 grams of potassium chloride formed in this reaction. Question 5. Calculate the mass of aluminium chloride that will be made if 15.4 grams of hydrochloric acid reacts with an excess of aluminium. The balance symbol equation for this reaction is there. Okay, so it's the same process. So work out the molecular formula of hydrochloric acid and aluminium chloride. Okay, same thing, use a periodic table, work out to find the relative atomic mass of each of the elements and add them together. Then we can work out the relative amount or the number of moles of hydrochloric acid. So that's going to be the formula of moles equals mass divided by mR. So the mass is 15.4 divided by 36.5, which equals 0.421. Now, this is where it's slightly different and can get a little bit more tricky. So the ratio there is 6 to 2. So 6 molecules of hydrochloric acid react to form 2 molecules of aluminium chloride. So the relative amount of aluminium chloride is 1/3 that of HCl. Okay, so 6 to 2 is 3 to 1. So it's 1/3 of it. So we need to divide the value we got of hydrochloric acid, which is 0.421, by 3, which is going to equal approximately 0.140. So that means putting that into our formula, okay, to work out the mass, we do moles times by mR. So we've just worked out that the moles are 0.14. We times that by the mR, 133.5, and that means we get 18.8 grams of aluminium chloride produced from that reaction. Okay, these are very in-depth, long questions. They will normally get you anywhere between 3 to 4 marks, possibly 5 in an exam, depending on how much information they give you and how much they want you to work out. But if you can understand it and do it, they're a really good way of really boosting up your marks in a chemistry exam. Have a quick go at the exit ticket. As I said, this is now a 5-mark question. Okay, so which is the limiting reactant in the equation below if I have 2.4 grams of magnesium and 2.4 grams of oxygen? So have a look. How would you work that out? Pause the screen if you need to. And I'm going to move on and go through this with you. Okay, so we know that 2.4 grams of magnesium and 2.4 grams of oxygen are reacting. Okay, and we've got the formula there. So 2 magnesiums plus 1 O2 molecule gives us 2 MgO. So that means we've got a ratio of 2 to 1. So 2 moles of magnesium will react with 1 mole of oxygen. So we work out the moles of oxygen, which equals 2.4 divided by 32, which equals 0.075. We need 2 lots of that, which will be 0.15 moles of magnesium. Whereas what we actually have by putting this into our formula, which is mass divided by mR, 2.4 divided by 24 is 0.1 mole. Now that is less than what is needed. Okay, 0.1 is going to be less than 0.15. That means that the limiting reactant is going to be the magnesium. Right, I hope this has been helpful. I know this is very complicated. Hopefully I've gone through it clear enough for you guys. But as I said, I recommend finding some exam questions on it, using the revision guides, using textbooks, and going through it. I will be setting some 6-mark questions on Showbie for you. Please have a go and just do the best you can. Hope you're all doing well. Thanks. Bye.